So sigma is this Greek letter that looks kind of like a weird E thing. This is sigma. It is a capital sigma.
So it's like an N on its side.
Or an N on its side, sure. Sometimes you'll see it where people put little thingies there. I usually don't because I'm lazy.
Some M's. My M's do not look like that.
Your name's don't look like
Well, like the
that.
mutual kernel one looks like that.
Sure.
Well, mine's like, I make my M's like curved.
Kernel.
Not just straight.
Anyway, with sigma notation, instead of writing out the terms, like if I had, 8 plus 10 plus 12 plus 14. If I didn't want to write them all out, you can use the sigma notation just to say, here's where I'm starting, here's where I'm going, here's how many terms I have, basically. It's just a condensed form of writing a series or or sum. So what we're going to do is we have the sigma here. It tells us n equals 1. That's our starting point, starting value of n. Starting value of n. Where we're starting. What would you put in for n to start with? K is where you stop. It's the max value, the maximum value of n. And then whatever you have to the right of the sigma is like the equation you're plugging your n's into, and it's just called the general form of the expression. So with my little example up here on the left part, how do we get from one term to the next? What do you do? Add what? What am I adding? Add 2. So n plus 2 would be my general form. So all we do is we're adding 2, and then I would put the sigma here. Where am I starting? What do I just put in for n to get 8? 6. Because I would put 6 here, 6 plus 2 is 8. So I would say n equals 6. That's where I would start. And then, what is my max value in? How do I get to 14? 12. So I would say to 12. So I'm saying put in is 6 first to get 8, and then go all the way up to n is 12 to get 14. Make sense?
So it isn't your starting numbers, but you get to your starting number?
Right. So what are you putting in for n to get your starting number? All right, let's do an example. Says write expression in expanded form and then find the sum. So in other words, they're just saying, okay, do what it says. It's saying put in n is 1 first, and then go all the way to n is 4. So we're going to put in n is 1, 2, 3, 4. Okay, so if we put in n is 1, what's 1 squared minus 3? So that's our first starting number. And sigma is like, it looks kind of like an S, so it says sums. We're actually adding these numbers here. Then we're going to put in n is 2, so n squared minus 3 would be 1. All right, then we're going to put in 3. 3 squared is 9, minus 3 is 6. And then last one's 4. Okay, so this would be in expanded form, and then it just says find the sum. So if we add up all those numbers, what do we get? Well, I think it's 18, if I did it right in my head.
Yeah, 18.
See, that's not so bad, isn't it? Super easy.
Yeah, you get it.
Yeah.
Okay.
Oh, what do you know? There's infinity.
There is an infinity. All right, so this one says start as n is 1 and go off to infinity. So obviously we cannot write off to infinity, so we're going to write the first like 3 terms and put dot dot dots. Okay, so if I put in n is 1, what do we get?
1.
1, because we get 1 minus 1 is 0, and equal to the 0 power is 1. So that's our first one. Okay, let's put in n is 2.
What if you sums?
So I can put the negative in. Yes. All right, what if we put in 2? Or excuse me, put in 3, so we just put in 2.
4 over 49.
Is it a positive or a negative?
Positive.
Positive.
Dot, dot,
And then we're gonna, yep, dot, dot, dot. And then we would just say plus, and we're just, instead of putting in, we're just gonna put the infinity sign. So we'll have a negative 2 sevens to the infinity minus 1.
I can't draw infinities.
You look at
Looks like an 8.
Just an 8 on the side.
Yeah, but I can't draw 8. I guess I can draw like 2
That's
circles.
what I do.
There you go. Draw 2 circles, that's fine. All right, so then if we're gonna find the sum, then we're gonna find the sum of a series like this, a geometric series. We have the sum is equal to the first term divided by 1 minus r.
It'd be 1 over 1 minus negative 2.
What was the able to write the sum of
Oh, you have
the
to,
definite term?
Well, let's look.
you have to,
Let's figure out if r, we have to figure out what r is and make sure that it's less than 1. Because then you can. Because our numbers are going to get
It's less than one.
it's 0.2, negative 0.25.
negative 1.25. How'd you figure out what r is?
That's not.
That's not what you got.
2 sevens
Negative 2 sevens minus 1.
divided by 1.
Divided by
That's
2.
not it.
Oh, divided by.
Yeah.
And you get 2 sevens. Oh,
No.
you get 7 threes.
7 twos.
No.
Oh, you get 2 sevens.
Negative 2
Oh,
sevens
wait, I got
divided
to do parentheses.
by 1.
Still got 2 sevens.
Negative 2 sevens. So that would be our r, so it would be,
Oh, it's
negative
negative 2 sevens to start with, okay.
yes. And the absolute value of negative 2 sevens is 2 sevens, and 2 sevens is minus or less than 1, then yes, we can find the sum of this thing. So, let's see, if I was going to put these at the 7, 8, 9, so it's a 1 over 9 over 7, which would be 7
How do you get
I was thinking this is a 7 over 7, 1 is, this is a minus, is a plus, so 7 plus 2 is 9 over 7. 7 nines. All right, any questions so far? All right. Example 2 says express this series using sigma notation. So we have to figure out first what the general form is. How do they get from one to the next?
Plus 9.
Plus 9. Is it a plus 9 every time?
No.
I don't think so. This is probably the hardest part to figure out how do we get from one to the next.
Can't you just take 24 minus or divide by 15?
Well, you could, but it's 24 to the
1.6.
So if you take that times 24, you get 235. So it's not geometric like that.
It's plus 9 plus 11 plus 13.
Okay. How can we use that? Can we use that?
You do plus r plus 2.
R plus 2.
R equals 9 plus 2. Like,
What?
you just add 2 every time.
That doesn't get you 20.
Kinda.
But we don't. I'm so confused.
Okay, let's finish. These numbers are almost all what?
You
Okay. Half of them are even, true.
divisible.
Okay. They all have the right way?
I don't know how you
What if we added 1 to every number?
If the 2.
What if we got over there?
Okay, what if we added 1 to every number? What would we have?
And then plus 1.
Okay, which is 16, 25, 36, 49. What are all those? Yeah, perfect squares. So, how can I go from a perfect square to get to 15?
Please go second.
Oh, let me just let's think. How can I get to 15 if I'm using perfect squares? Well, what's the perfect square that's close to 15?
16
And how do you get 16?
plus 1.
4 squared, and then if I go 4 squared is 16, how do I get to 15?
So it's n squared minus 1.
Will that work over here?
Yeah.
Yeah, because if I put in behind it, 5 squared minus 1, it says 24. If I put in 6 squared minus 1 is 35, right? So our general form is just going to be n squared minus 1.
Oh, no.
Me either. Never mind.
Okay, then we have to figure out, okay, what do we put in for n to get to 15? We just said 4. So n is equal to 4 goes on the bottom. And then we have to think, well, we're stopping at 143. So what's the number that we put in for n to stop? 12. It's 12 squared is 144 minus 7. So that's what you do there. Alright, in factorial. In factorial. I know it looks like exclamation point, like it's like, in, woo! You know, I was with my sister looks at that, she's always like, I'm so happy. And it's satisfying. Anyway, in factorial, is defined as follows. So, in factorial just means take itself times the number below it, because the number below that, because the number below that. So, like, I was going to go with a 4 factorial, that means take 4 times the next number down, times the next number down, times the next number down, all the way to 1. So 4 times 3 times 2 times 1 is 4 factorial, which would be 12 times 2 is 24 times 1 is just 24. So in factorial would be 24. Does this make sense? So if it was like in, or 25 factorial, it would be 25 times 24 times 23 times 23, blah, 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 all the way to 1. So that's why they give you that handy dandy little button in your calculator so you don't have to multiply.
What means we do that about
It should be in factorial. It's usually say 18.
I have this one.
Push PRB.
Oh, and PRB, probability, you go, there it is right there. So if we would go like,
We should do the power.
factorial. Yeah.
So,
Anyone else?
Check on it. That is.
Yep, that's it. So you're going to go number, and then I got it. There you go. You got another one?
yeah.
Okay.
I don't know if this is a real world application to this.
Okay.
I was listening to the radio this morning when we were at school. It said that the state Powerball or whatever is like 222 million now. And I think how the Powerball is played, there's like 6 numbers, and they have to, like, it's anywhere between like 0 and 99 or 1 and 99. I don't know for sure. And then, yeah. So we should do a problem on how many possibilities there are, and like if you would buy every single possibility, like would you get your money back?
No, thank you.
We'll have to check it out. We'll have to do some research.
You totally should.
No.
We'll finish this problem and then we'll figure that out.
You. I'm doing that.
All right, so this one's a successive series using sigma notation. So I would look at these fractions and I would just concentrate on first the top, the numerator. How do we get from one to the next?
Count 2.
We just take it times 2, right? So I'm going to say that the top of our fraction is going to be 2 times n.
Bottom, wait, no.
Not quite.
Okay, so what are we doing?
We're trying to find the general form of this, because that's what us to put it in sigma notation.
So
3,
and
What about 3?
The general form?
The general form. So like what we did up here, like right here where we had the n squared minus 1, that. How do you like a little formula of how to get from one number to the next?
you do like times 3, times 4, times 5, times 6.
I don't know how,
Okay.
I don't know how 2n is the top.
Because if I put in 1 times 2 is 2. If I put in 2 times 2 is 4. If I put in 3 times 2 is 6.
Oh, I don't like that.
Okay, so how can I get to the bottom? What were you saying about something about 3?
2 times 3 equals 6. So, oh wait, that's negative 6. Do we have to bounce back and forth?
Well, yeah, we do. How can we bounce back and forth between negatives and positives?
Put a negative and the
Wait, so is this a factorial?
Is it a factorial? I don't know. You tell me.
No.
I don't know how this stuff.
Let's think. If I try 1 factorial, I'm just going to get 1, right? What's 2 factorial?
2.
2. So if we're saying n is 1 here, because 1 times 2 is 2. If I'm saying n is 1, I get to 2 using a factorial.
3, oh, it's like n factorial is what it is.
Close, because if I'm saying n is 1, but factorial of 1 is just 1. How do we get to 2? Add 1. So we have n plus 1 factorial. Let's try it over here, because I know this is, if I take it and put in 3 for n, 3 times 2 gets us 6. 3 plus 1 is 4. It's 4 factorial 24. Yeah, we just got it over here.
Also, you're using
Okay,
factorial?
but now we need to add the negative to it.
Right, we have to bounce back and forth from negative to positive. How do we do that?
Put a negative in front.
Let's put a negative from here, and then they're all negative. Do that.
Negative.
To the negative.
So the negative n,
N minus 1.
so the negative n minus 1. Like that.
No,
Just
times.
N minus 1.
Use my n minus
Yeah.
1. Like that.
No, times n
No, that's
You're
not.
not
to
counting
the negative 1.
Times n to the negative 1. This.
No.
No?
Yeah.
Well, this is going to make it negative, so it's not.
Negative n plus 1.
Negative n plus 1. Like this.
That's 2.
Oh, sorry.
Wait, so you need an exponent?
Hmm?
Do you need an exponent?
Well, do we?
Okay,
Negative 1 to the n.
Negative 1 to the n.
So you're trying to figure out how we get from one number to the next.
Right, because we're starting with a positive, then we have a negative, then we have a positive, then we have a negative, negative, positive, then we bounce
So
one to the
N
next.
and that is
so what's n?
negative 4, 6.
N is the number we're looking at, like 1, 2, 3,
You go in order.
go in order. Always.
Also, N isn't like 6 over 24.
No. N is whatever number, like, we're putting in N is 1, N is 2, N is 3, N is 4, N is 5.
It's not working.
So I know over here, with the sigma notation, I know we're starting with N is 1, all the way to N is 5. So we have 5 terms. But we still have to figure out how to get from negative to positive. I'll give you a hint. It has something to do with negative 1 to something power.
N plus
N plus 1?
1. What is 1?
That's 2. That's Okay, well, let's try it. So if I put it in line, we're going to get 1 plus 1 is 2, so negative 1 to the 2 power is going to be a positive, right? Which it is true because we went positive for the first one. If I put in a 2, n plus 2 plus 1 gives us 3. Negative 1 to the third is a negative 1, which is what we want, because our next term has to be negative. So yeah, that works.
Is there any other way to write this?
I don't think so.
Get how you're supposed to know how to do
Yeah, I don't either. I don't.
Like, you can some tips to look at, right?
All the stuff I would not be able to do. I don't think I could do it on my own.
I think you can try. I think you can
that. How most of the equations are complex.
I'll give you like, okay, if you have a negative, positive, you're always going to have a negative 1 to the something power. Okay, to get it from negative to positive. So you're always going to, I would always start with this. You're going to have it to the power of n plus 1 or the power of n plus 1, or the power of minus 1, something like that. If you look at the bottom of this denominators here, and you know that they start really tiny and then get big really fast, it's probably going to be a factorial. Yeah, look for squares, and squares turn up a lot in patterns for some reason. Just have to play with things sometimes and see which way we can get it to work with all numbers. Alright, over. Come on, Riley. Are we not responding? Alright, just look it up.
There it goes.
Nope, there we go. This one. Oh, let me put it down. I have to look at the book anyway. Goodness gracious. Good time. 4, 5. Alright, page 798.